Dear students, in this video, we are going to see one of the most important concepts in current electricity. How to find out the effective resistance when few resistors are connected in series. First of all, we have to understand what do you mean by resistance connected in series. Let me show you through a simple circuit how to connect few resistors in series. See here, this is a voltage source. Here we have a voltage source and it's connected to resistance R1, R2 and R3 respectively. The moment we complete this circuit, you know that electric current, the conventional current will be flowing from the positive terminal of the dry cell to the negative terminal. That means the current will start flowing from this point. Let I be the current starting from this terminal. The same I will be passing through this resistance. The same should be passing through R2 and R3. See, the same current will be coming back to the negative terminal of the battery. So this is a complete circuit. The most important thing you have to understand in the circuit is whatever current flow start from the positive terminal should pass through all the three resistors in the circuit and should come back to the negative terminal. In reality, you know that electrons are flowing from negative terminal to positive terminal, that is known as electronic current, and this is a conventional current. First of all, when you connect resistors in series, that can act as a voltage divider. What do you mean by voltage division? Whatever voltage you are applying here will get distributed here. That means here you will get a voltage V1 across this R1 and V2 across this R2 and V3 across R3. We can apply Ohm's law. All of you know that V is equal to IR, voltage proportion to current, and V is equal to IR. So when current I passes through the circuit, when current I passes through the resistance R1, the potential drop across that resistance is going to be I multiplied by R as per Ohm's law. You already know that. So V1 is going to be equal to I multiplied by R1. Similarly, V2 is going to be equal to I multiplied by R2 and V3 is going to be I multiplied by R3. Look here, voltage division means whatever you are applying here is distributed across these resistors. So if you are putting a voltmeter across the resistance R1, you will get a lower voltage compared to whatever you applied in the battery or in the dry cell. So voltage division is happening. So the first thing you have to understand is whatever you applied here, as per energy conservation, we can say that whatever voltage you applied here is distributed across this resistance. That is going to be the sum of this distribution. Sum of V1 plus V2 plus V3 should be equal to whatever you applied in the energy source, provided there is no internal resistance. We are talking about the ideal case. Fine. So let us write down the equation. Whatever voltage you are applying in the circuit, V is going to equal to current multiplied by R1 plus current multiplied by R2 plus current multiplied by R3. Now assume that you are trying to find out the effective resistance. The effective resistance we can write down like current multiplied by the effective resistance REFF. I am putting effective resistance. So effective resistance will be equal to current multiplied by, I can take I common, I can write on I R1 plus R2 plus R3. Now see, you can easily cancel this I because both are same value. So you are getting the final expression. So look here, the effective resistance is going to be equal to the effective resistance when you are connecting three resistors in series. R effective is going to equal to R1 plus R2 plus R3. Same way, if n resistors are connected in series, you have to add in a same way. So this is the final expression for effective resistance when you are connecting three resistors in series, or it can be extended to n resistors connected in series. I hope all of you understood this thoroughly.